Hello everyone, this is Alpana Negi. I am an iOS engineer at PayPal Bangalore, and I'm very excited to talk to you about how Xcode 11 allows us to create and distribute binary frameworks along with the best industry practices for framework author considerations while creating the binary frameworks. So let's dive in. What are frameworks? Framework is a bundle and its contents can be accessed using in a similar fashion like Core Foundation bundle or Cocoa's bundle class. However, unlike most bundles, a framework bundle doesn't appear in the Finder as an opaque file. So they are highly reusable components and maintain a hierarchical data structures directory structure which encapsulates shared resources, libraries, image files, localization files, and public documentation. The framework serves the same purpose as a static and dynamic shared libraries. That is, they provide a library of routines, and those routines can be called by application to perform a specific task. There are few advantages which frameworks offer over and above static linked libraries or other types of dynamic shared libraries. Frameworks are easier to install, locate, and uninstall, and all their resources are in that single package. And only one copy of the framework's read-only resource resides in physical memory at any given time, regardless of how many processes are running and using those resources. This sharing of resources reduces the memory footprint of a system and results in improved performance. Multiple applications can use the same resources and included in these frameworks simultaneously. So the developers so if you have an application which or a bunch of applications which has some core functionality, usually corporate applications will have a core functionality which will be in all the applications. You can extract that core functionality out of multiple apps developed by your organization and build a framework out of it, or you can use external frameworks based on your requirement. How applications and frameworks work is that an application can use a single framework or multiple frameworks, and those frameworks can in turn use other frameworks. So when an application embeds in a framework, the functionality of that framework is pulled into the application and can be used with the public calls from that function. So from any of the classes. So with older version of Xcode, you would have seen this error or a variant of this error which states that compiled module was created by a newer version of the compiler. What used to happen is if you had created a framework with Xcode 10.3 and a newer version of Xcode and a Swift compiler launched or got published in the App Store, at that time, if the applications are using the version of the framework which was developed using the Xcode 10.3, so the compatibility is broken because the Swift version is different in the application from which the framework was developed in a different version. So framework developers either will use later betas or GM builds to upgrade their framework to be in line of the Swift compiler version upgrades. This issue resulted in two different approaches. One is Swift packages and other one is the XC framework. The Swift packages also were introduced in Xcode 11, and they are similarly they are easy to use and create and distribute. In case of Swift packages, Xcode knows how to manage their dependency, and it knows which version of the package to use. They are distributed in source form, so there is no requirement to maintain binary compatibility. So if you ship the source code of your project, then Swift packages are a great way to go forward. But not all the developers or corporates would want to ship the source code, and that's why Xcode 11 supports distributing binary libraries using XCFramework as well. So in case of XCFrameworks, this is like a normal framework, but it can be bundled up with multiple variants of your framework so that it works in across Xcode versions going forward. So let's say if you are developing, if your minimum Xcode version supported is Xcode 11, if you create your framework, XCFramework, using Xcode 11.0, it'll be working on all the upcoming releases of Xcode if your framework is created with XCFrameworks. In case of XCFrameworks, a single package contains multiple architectures, platforms, and simulator architectures. It will contain different device variants and OS variants as well. So you can have one single framework for iOS, which supports iOS, Mac OS, tvOS, and watchOS. In case of dot frameworks, the framework developers usually had to give dot framework which has both device and simulator architecture, and a dot framework which just had the device architecture, because when uploading the applications containing dot frameworks to App Store, the store will throw out an error if the simulator architecture is included in the dot framework. The error will state that the IPA containing simulator architecture cannot be uploaded to store. So to do that, either the framework providers will have to provide a framework with just a device architecture, or the application developers will have to strip off x86 64 architectures. And then there was a need to create a fat binary using LiPo when using dot frameworks. Both of these points are no longer required in case of XCFramework, and then it keeps track of DSIMs. So if there is a crash in the application, the debug logs can easily be accessed, and the root cause can be found easily. So how do we create XCFrameworks? It is done in 3 simple steps, wherein first is to enable build libraries for distribution under build options, and the next one would be to run 2 different commands. One is for archiving the output, and one would be for creating the XCFramework, wherein the input would be the output of the previous command. Okay, so you will have to choose a template wherein you can go to frameworks and libraries section and select framework for creating a framework. In the build option, select build libraries for distribution. Just write your public methods, test it, archive it, and ship it. So when running xcode build command, you will have to run that command once for physical device architecture and once for simulator architecture. The and then archive command, in when running archive command, you will have to give a scheme and a destination or a set of destinations wherein you will either once give IO simulator, and next time you will give the iOS device, and then there will be an argument called skip install. That skip install tells the xcode build archive command to install the framework in the resulting archive. This command will build the archive of each variant of the framework. So in the previous section we are generating multiple variants. This command will build the archive for each variant. Now we'll need to extract the framework, the dot framework, and bundle them as XCFramework. For that we'll need to run xcode build command hyphen create framework. In this command, the output generated from previous commands, which would be a dot framework, will be used as input and will be giving a name to the resulting XCFramework and a path to that framework. So let's move to demo, wherein we can just go to Xcode, and I have created a demo app which doesn't have anything, just has a plain screen and has a show passcode button which currently does nothing. Now I have a framework which is responsible. Let's say I have a bunch of apps, and for all the apps I want to show the passcode in a similar fashion. It should have the same policies. So what ideally I would do is I would create a framework, and all of my, let's say, internal apps will use that framework, so that there is a similarity between all the passcode screens of my app. So to include an already created framework, I have kept an already created framework in here. I just have to drag and drop here and finish it. The one thing I have to do is, if you are running on device, just do it embed without signing or embed and sign, depending on whether you are signing the framework or the application developers have to sign it. And then just import the framework, and whatever public functions are provided by the framework providers excuse me, are can be called in whichever view controller you want. So by writing just one line of code, since the framework provider is giving a passcode screen, I can get a passcode screen which is just an overlay over the current one, and I get the callback as passcode screen shown, and then a bunch of prints from the application. So this is where the application will get the control back, and it can be achieved in multiple ways. So this is from the application side. Now to create frameworks, you will have to choose the template as frameworks and write a bunch of public classes and public initializer maybe, or a static shared instance, and some public functions which can be called by the caller application. And you can list out the public enums or structs if they are accessible from outside. So once you have all your classes and methods ready, what you have to do is you will have to build the framework and run scripts, or you can either you can run scripts or you can manually do that via command line. So to run scripts, the first step was to archive the frameworks. Here we are just creating the directories to keep the frameworks once generated. To archive the framework, once we'll have to give the we will have to archive for the simulator version, and then when you are archiving for the simulator version, the SDK will be iPhone simulator SDK. Then you'll have to give the archive path, and scheme is the framework name, and skip install is set to no as to state that the build archive to install the resulting archive in the resulting build in the archive, and then turn on the build libraries for distribution. Then for the similar thing for iOS device, wherein the archive path will be device path, which are defined here, and then you will give the SDK as iPhone OS and similar parameters to be passed. Excuse me. So the next step would be to create create XCFrameworks out of those out of these frameworks, and these frameworks will be used as an input. So the one of the framework was for simulator path, and the other one was for archive path, which are used as an input here, and then the framework path which will be generated is going to be of an extension of XCFramework. So when I run this, this framework will be generated. Now this framework is if you inspect the contents of the framework, it will have a Swift interface file. So this Swift interface file will have the metadata about the process, and then what the underlying framework is, what other frameworks is the underlying framework using, and the public shared instances, public functions. Since we if you notice, we haven't written a D in it, but this generates, the compiler generates the D in it for us, so that it doesn't make any assumptions if in case we haven't written it. The enums are also, the public enums are also listed. None of the function body will be written, it will just be the definition. The enums are listed here, and then it'll conform to hashable, and then if the in the interface explicitly confirmation to hashable is done, so that the compiler derives the required methods if we don't write them. So that .swift interface, module interface files fixes the problems which were in the earlier versions of Xcode, because they were compiler dependent. Now since the nothing is no assumption is made by the compiler, and everything is in textual listing, all the public APIs are textual listing, are in textual listing, the compatibility between compiler versions is intact, and this is enabled with build libraries for distribution. Now moving on to developer considerations, what the developers should do what the application developers should do when using a third-party framework, and what the framework author should do when building frameworks. So in case of application developers, make sure you trust the source of the framework. Always run all the edge cases around the framework which we may encounter, and make sure there are no corner cases or unattended bugs or crashes in the frameworks, because the framework is going to be part of your applications bundle, and the reviews are directly gonna, if the framework crashes, and then your application also crashes, and the reviews are going to impact your rating. For framework author considerations, trust that users data is handled correctly and users privacy is always respected. So if the apps are granted permissions such as use of location service or camera or photos, then the framework will also get those permissions, and it's a application's responsibility to make sure that the requested entitlements are added in the application. So when for framework author considerations, you will always follow the semantic versioning, wherein a major, minor and a patch version will be listed in the plist under bundle version string short. So this plist can be seen from outside, and the consumer applications know that which version is being used by just looking at this plist, if you are not publishing it anywhere else. It's always a good practice to put the version of your application in your framework bundle in the readme or public documentation. So in case of versioning, starting from the rightmost side, the third component would be a patch version, and is meant for bug fixes or internal implementation changes or performance optimizations. This should never affect the current implementation of the consumer app of in the consumer applications. The second version, the example of the previous one could be adding of a private property, which doesn't need to, adding of private property won't need to be changed, anything won't need to be changed from the consumer application side. The second component is called minor component, and it's usually used for backward compatibility. So in this you will upgrade the minor version when new APIs are added, or when you have additional capabilities, new public when new public methods are added, then upgrade the minor version, and after upgrading the minor version, just reset the patch version to 0. In that case, the leftmost component is a measure component, which should only be used for breaking changes. The breaking changes could be source breaking or binary breaking or semantics breaking. When you are upgrading measure version, that indicates that a redo from client side might be required. So what comes under this is if you are changing the definition of a current public method, even if you are giving a default value to newly added parameters, in case you are adding a parameter, it still will need a measure version upgrade, because Swift identifies the functions by name and parameter combinations. So since a new parameter, it's handled as a breaking change. For further developer considerations, it's since the frameworks are going to be used in a lot of applications, the framework author should always should always be managing the dependencies, And then framework authors always want the flexibility to change, add, or remove or improve the framework without breaking things. The flexibility and optimization is handled with build libraries for distribution. What this does is this generates module interface file, which we saw some time back, and sets the default to flexibility, so that there are minimal breaking changes. To if you as a developer want to have higher optimization, you should only do it after profiling, and it can be achieved with making inlineable functions or frozen enums or frozen structs. If the framework should be evolving over time, but it should follow the same semantic approach as shown earlier. And if the frameworks are requesting for entitlements, always document them, so that application developers are aware of the entitlements request which might come from framework side. And then the entitlement request should be kept to minimal, and so does the dependencies. Lesser dependency is directly proportional to lesser framework size, since the frameworks are going to be on top of app size, so it's good to have it on a lower level. And a lot of application developers do consider size as a factor when adopting any frameworks. Listen to the customer feedbacks, because usually you'll have the same functionality, but a lot of times it's not just public yet, you internally have it, so it's just making it public from your side, and the customer gets the additional functionality. When doing API designs for frameworks, always keep your documentation up to date. Even if there is a patch version change on your framework side, make sure that everything which needs to be communicated to the client or customer application is in there. Even if you are making performance changes or optimization changes, just make sure that they know about it, and can make the adaptation decision based on whatever is written in the documentation. And then they define the names clearly and carefully, so that it doesn't it's still relevant after 2 months or 6 months. Once you have released the apps, it is going to be harder to rename functions once it's out in public. Keep the interfaces small and precise, and so that it does only whatever is needed to do, nothing more, nothing less. You should always avoid extensibility, and by that I mean, if you have to choose between open and public, go for public, so that in future it's going to be easier if you have a requirement wherein you have to go make a class public, so public class open, it's going to be easier rather than going back from public to open. And public to open is always going to be easier than open to public. And always keep your requirements clear, and handle errors gracefully. Your framework should never exit or return unexpectedly, and there should always be a callback or delegation from your framework to the applications, so that since a lot of frameworks takes full screen control when embedded, so that the customer application is not hung in between. If uh, if they include if they include your framework. Other than this, if a framework doesn't have an Objective-C code, you can turn off install Objective-C compatibility header to no. And if it's not going to be having a .h file or generated headers, you can just set define modules to no as well, so that it's going to be purely a Swift framework, and it's going to be used in Swift applications. For distribution purpose, you can either have your own channel wherein someone authenticates and then can download the framework from your portal, or you can rely on already existing channels like CocoaPods or Carthage. And that's all we have for binary frameworks today. Thank you so much. Have a great day.